Today we're starting trigonometric functions. This will be an overview. We're going to be covering Unit 8, Lessons 1 and 2, moving circles, and the unit circle. So pick up Unit 8, Lessons 1 and 2 packet from the blue basket. If you're not at school, there'll be a link in Google Classroom that you can follow along and work on your own paper, and you can pick up the packet when you return to school. So begin the bell work on page 5. Remember our class expectations. We've been pretty consistent since the beginning of the year. Come to class ready to learn. Stay on task, chat and work only about the topic, be fully engaged, answer questions, participate in discussions, use your calculator or Desmos when asked. In fact, have your calculator or Desmos open, ready to go. Go to the board to help when asked. Communicate if you aren't ready, you need more time, etc., but you need to stay focused on what we're doing. Everyone will help students and teachers at the board, so don't feel like if you don't know what you're doing and I ask you to go to the board, then I'm going to ask you to go through every step. I'm not putting you up there to embarrass you. I'm putting you up there to help us all. And I can't always go up to the board and write, so I need students to volunteer to go up and help. And sometimes that's a random call out. Ask and answer questions, and remember, no food or drink other than water. And I don't like water as well, but I will tolerate water at your desk, but that's it. Nothing else. Pencil, paper, tools to learn. All right, lessons 8.1 and 8.2 are learning targets. I understand that a periodic function is one with outputs that repeat at regular intervals. I can use the Pythagorean theorem to find coordinates of points on a circle centered at the origin. I understand how to use trigonometry to express the coordinates of a point in quadrant 1 that is 1 unit away from the origin. I can recall definitions for cosine, sine, and tangent of an angle in a right triangle. I understand that points on a unit circle can be defined by their coordinates or by an angle of rotation. I can find different angles and their coordinates on the unit circle, and I can use definitions for sine and cosine that work for angles larger than pi over 2 radians. And if you recall from what we looked at this year, pi over 2 is at 90 degrees, so we're talking about the first quadrant. So turn to page 5, complete your work in your packet, show your work, which choice is equivalent to the expression shown below. So pause the video now if you're watching at home, work it out, and then come back to see the solution.
Jingle bell, jingle bell, jingle bell rock. Jingle bells swing and jingle bells ring. Snowing and blowing on bushels of fun. Now the jingle hop has begun. Jingle bell, jingle bell, jingle bell rock. Jingle bells chime in jingle bell time. Dancing and prancing in Jingle Bell Square. In the frosty air. What a bright time. It's the right time to rock the night away. Jingle bell time is a swell time to go gliding in a one-horse sleigh. Giddy up, jingle horse, pick up your feet and jingle around the clock. A mix and a mingle and a jingling feet.
All right, welcome back. We're looking at 48x cubed minus 243xy squared. We have a binomial, but we only have two terms, and it's a cubic. All right, I'm going to look first at the 48 and the 243 to see if they have a common factor. So I know that 48 is divisible by 2, but 243 is not even. It ends in 3, so it's not divisible by 2. So let me go up to the next prime number. Let me try 3. Now the trick is add 8 plus 4, add all the digits together. 8 plus 4 is 12. 3 goes into 12, so 3 goes into 48. So 48 divided by 3, of course I'm working at the board, but you've got your calculator. 48 divided by 3 is 16. Always double check my work, because I'm not using the calculator. 16, I still have the x cubed if I divide a 3 out. Okay, and then minus 4 plus 2 is 6, 7, 8, 9. So these digits add up to 9. 9 is divisible by 3. So 243 is divisible by 3. All right, use your calculator. It goes much faster. 3 goes into 24. 6 times 3 is 18. 3 times 8 is 24. So that goes in 8 times evenly. And then 3 goes into 3, 1. So I think that this is correct. And then I still have my x, y squared. So now I'm looking at both terms, and I'm looking at my answers. Both of these terms, if I look at my variables, have at least one x in them. That's all they have in common. So I can go ahead and divide that one x out. So let me factor this again. 3x times 16 divided by, we've already divided the 3 out. Let's divide the x out. 3 minus 1, we've got 2 on the top. I'm sorry, 3 on the top. X times x times x. And 1 on the bottom. So one of those is going to cancel with the 1 on the bottom, and we're left with 2 on the top. So we're left with x squared. So we still have that 16. We're factoring out an x. That's messy. Let me erase that. I don't like that, but I want to make sure that you can see it. All right, so we're factoring out a 3x, and we're left with 16x. 3 times 16 is 48. 3 times x, I'm left with x squared. Minus, and then we already factored the 3 out. Let's factor an x out of this term, and we're left with 81. X over x is 1, and we're left with y squared. And we need to factor again because I see my answers are factored, but it's not going to be just the 3 that's factored out. So we can eliminate this answer, A, and this answer, B. All right, now we have to factor this part. And we don't have a third term, so I'm looking at it to see what do I know about these two terms. We're subtracting. That's a difference of squares because 16x squared is a perfect square and 81y squared is a perfect square. Look on the board, the square root in the back of the room, the square root of 16 is 4. The square root of x squared is x. The square root of 81 is 9. And the square root of y squared is y. So we're going to write that down, put it in parentheses. We're going to write it twice. Okay, 4x and 9y. Now I'm looking at my answer choices. That kind of helps me. Okay, so I do have it factored into 4x and 9y. Up here, I have minus and minus. Now, if you FOIL this out or you put it in a rectangle and multiply it out, you're going to get that middle term. That middle term is going to be 9 times 4 negative 36 twice, negative 72 xy. But here, it's going to be negative 36 xy and positive 36 xy. You're not going to have a middle term. So I'm looking here. This is a difference of squares. It factors into the square root of the first term, square root of the last term, and you put plus and minus. So our answer is going to be answer choice D. All right, we're asked to calculate the length of side BC. So this is a bridge. We should already know the Pythagorean theorem. A squared plus B squared equals C squared. So highlight or label what you know. The shorter sides are going to be the legs. The legs are what makes up the right angle. So we already have one of the legs. You can label that A or B. I chose to label that A. And then the hypotenuse is always going to be labeled C. So C is 15. All right, we're going to use A squared plus B squared equals C squared. Now let's substitute in 12 for A and 15 for C. 12 squared is 144. 15 squared is 225. We're solving for B. So we're going to subtract 144 from both sides. 144 minus 144 will be 0 on the left. So we have B squared equals 225 minus 144 is 81. Take the square root of both sides. Square root of B squared and the square root of 81. Okay, so the square root of B squared is B, and the square root of 81 is 9. So now we can label that missing side BC. Has a measurement of 9 units. Now looking at question number 2, we have the hypotenuse. That's 10, the longest side, the side opposite the right angle, but we don't have the legs, so we want to find both of those legs. What we do have is we have an angle of 37 degrees. So we're going to have to use our that's our trig ratios, SOHCAHTOA. I have that first one wrong here. Let me mark through that. Should be SOH. Some old hippie came a-hoppin' through our apartment. There are different ways that students have told me they've been taught. I don't like the tripping on acid one, so I'm going to stick with some old hippie came a-hoppin' through our apartment. All right, write these notes down in your workbook on page, I think we're on page 5. Sine of theta equals opposite over hypotenuse. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So pause the video if you need to write that down. All right, now coming back, we know we have theta, so write down what we know. Theta equals 37, and we have the hypotenuse. Hypotenuse is 10. Okay, now we're looking at 37, and what's opposite of theta, angle that's 37 degrees, is A, and we have the hypotenuse. So we need the opposite over hypotenuse function. So we need sine to find A. Now looking at angle 37, angle theta, the adjacent side, the side that is part of that angle, is B. I labeled it B. That's adjacent to 37. So to find that length, we're going to need cosine, adjacent over hypotenuse. So let's start with A. A is opposite over hypotenuse. The opposite we don't know, so we're going to use the variable A. Over 10, 10 we do know the hypotenuse, equals sine of theta, which is 37. Now we're going to replace theta with what we know. Now we're going to multiply both sides by 10 so that we can eliminate the division by 10. And we're left with A equals sine 37 times 10 on the right-hand side. So that's what we'll put into our calculator, sine 37 times 10, and we get approximately 6.018150, and you can read the rest. It says round to the nearest whole number, so rounding that to the nearest whole number is going to give us 6. So look at what we solved for. We solved for that shorter leg. We solved for A. That was opposite of 37. So A is equal to 6. Now we're going to use the cosine to find B. Again, we still have theta that's equal to 37. Now we are looking for the adjacent side, which we don't know, so use a variable over the hypotenuse. The hypotenuse is 10. Multiply both sides by 10, just like we did before, so that we can get that variable by itself. And then we'll be left with 10 times the cosine of 37 equals B. So put that into your calculator. 10 times cosine 37, you will need to use your functions, and you will get approximately 7.986355, so forth. Rounding to the nearest whole number, that rounds to 8. So we're going to put 8 up there by B. All right, so you can check it too. A squared, 6 times 6 is 36, plus B squared, 8 times 8 is 64. I get crooked here. 64 plus 36 is 100. Square root of 100 is the hypotenuse, 10. All right, now let's look at the warm-up on page 6. Take 1 minute to think and make a choice on your own. When the timer goes off after a minute, I want you to discuss with your partner for another minute and choose one between each of you, okay? Go up to the board and make 1 tick mark next to your choice. Also, we want to be ready to explain why, if you're called on, why you chose that. There are a multitude of reasons, but I want you to think about relating this to angles and arc length, what we recently studied, or angles and sector area. See if you can do that. All right, pause here before going on if you're doing this on your own. All right, welcome back. Some things that I noticed or that you put on the board. Quickly, I'll go through these. This cuts or subtends 1/4 of the circle. Okay, 1/4 of 60 minutes is how many minutes? In other words, what is 60 divided by 4? How many minutes is that? That would equal to 15 minutes. You've got to think about your ratio, part over whole. Our whole, in terms of minutes, is 60. Another thing that I noticed about this one is that it's the only one that keeps, if I'm thinking about a circle, that keeps everything in that first quadrant. Okay, there's some other things that you might have noticed. I'm just going to go through this quickly. This is the only one also that forms a right angle. All right, for B, okay, this is the only one that is not pointing in any way to 12. So 12 is not being pointed to. You see anything else? It's also not pointing to those numbers exactly. Okay, this arm is pointing somewhere in between 1 and 2, so it's harder for me to see exactly where it's pointing. C is cutting out 2 sections. 2, okay, that's 5 minutes, 10 minutes, 10 out of 60, so 1/6 of the circle. Okay, in other words, 1/6 of 60 is 10 minutes. And this one's cutting out 5, 10, 15, 20 minutes out of 60, or 2/6 if you divide by 10, and then divide by 2 and you get 1/3, so that cuts out 1/3 of the circle. Okay, there are different things that you could have noticed.
The first one that stands out to me is probably this one right here for B, because it's the only one that with the minute hand at 30 minutes, it's not on the hour. This is 4 o'clock, 3 o'clock, 10 o'clock. So that would probably what I would pick. You might have said A because it's the only clock that forms a right angle with the hands there, if you're thinking geometrically. Same idea with C, it's the only one's forming an acute angle with the hands. And then for the last one right here, you could say it's the only clock with the hour hand pointing downward. And I know it's not going directly down, but the hour hand is pointing in the downward direction, whereas you look here, upward, to the side, upward. This is the only one going down, I guess. All right, so let's take a look at this problem here. A ladybug lands on the end of a clock's second hand when the hand is pointing straight up. The second hand is 1 foot long, and when it rotates and points directly to the right, the ladybug is 10 feet above the ground. So I kind of got this picture drawn here. Here's the clock on the wall. It's obviously not drawn to scale if my radius is 1, or my second hand is 1, and then it's 10 feet above the ground when it's to the right. But you kind of get the idea here. This is 10 feet from when it's to the right to the ground. Okay, so how far above the ground is the ladybug after 0, 30, 45, and 60 seconds have passed? So 0 seconds, it starts, let's see, let me read this again. At the end of it, all right, so 1 foot long. So it starts up top, but when it's to the right, it's 10 feet above. So the radius is 1, remember? So at 0 seconds, it's 11 feet above. At 30 seconds, it's kind of like down here. So it's really 10 minus 1. So that would be 9. 45 seconds, it's back up to where it started, or back up to where it's exactly 10 feet above. So that would be at 10. And 60 seconds, it's back up to where I started. So it's going to be back up here at 12. So it's really 10 plus the one foot. So it's going to be 11 again. And then it's going to kind of repeat the whole thing over and over again. So, all right. So the next thing says, pause here for class discussion. So obviously the maximum height is going to be when it's up here at 12. That's going to be 11. Maximum height of 11 feet. And a minimum height is when it's down here at the bottom. Down here, that's going to be 9. And anything in between would be between 9 and 11 feet. So if the ladybug stays on the second hand of the clock, it will continue going around. So it's going to kind of repeat. It's going to kind of, get back up here to 11. And it's going to start decreasing. It'll be, the minimum will be at 9. And it starts increasing. It gets higher, back to 10 at the middle, all the way up here at the top. You're back at 11 feet. Estimate how far above the ground the ladybug is after 10, 20, and 40 seconds. So 10 seconds are right there. A little bit greater than 10, not quite at 11, not halfway. I'd say, I don't know, maybe it is halfway, actually, if you look here. I'd say maybe 10.5, roughly. 10.5 feet at 10 seconds. 20 seconds, it would be down here. So it's kind of the same thing. If I said it was 10.5, it's like I'm subtracting 0.5. So I'm gonna guess it's 9.5 right there. I'll write it up here so you can see what it is. And then 40 seconds is all the way right there. So that's kind of the same as right there at 20 seconds. If you look here, they're kind of like the same height. If you think about it right there, whether my hand is at 40 seconds or over here at 20, it's the same height. So I'm going to say that's probably 9.5 as well. Again, it's an estimate. It's not necessarily exact. It could be 9.4, 9.6, not really sure. It's definitely less than 10 though. Number 4, if the ladybug stays on the second hand, describe how its distance from the ground will change over the next minute. What about the minute after that? So you're going to start at 11 feet above the ground, decrease till you reach 9 feet above at 30 seconds. then start increasing the height until it reaches 11 feet at 60 seconds, and it will continue to repeat. Okay, and I kind of already did that, but start here at 11. It's at 10 at 15, 30 it's down at 9, and it starts increasing, the height's higher. 45 it's at 10, 60 you're back up to 11, and then it just repeats over and over again because it's going to keep going around. Okay. All right, at exactly 3:15, ladybug flies from the second hand to the minute hand, which is 9 inches long. How far off the ground is the ladybug now? So at exactly 3:15. So you're at 3:15, you're on, let's see here. Flies from the second hand to the minute hand. So the minute hand is right here. Well, if the minute hand is 9 inches long, right here, it's kind of the same height as the second hand. It's equally, it's not quite as long here. Maybe I'll shrink it down. Second hand's a little bit longer than the minute hand. So maybe if I make it like that, still the same height, whether it's, I'll put another hand here in a different color. Let's see here, maybe the second hand is in blue right here. If it's longer, it doesn't matter. The height's still the same. It's going to be 10 at 3:15. So this is going to be right here. It's going to be 10 feet. Okay. One more. At what time will the ladybug be at that height again? If it stays on the minute hand, be prepared to explain your reasoning. So the minute hand was my red one here. Let me just swing that over. I got to get back to the same height. It's right here at 45. So that's 30 minutes later. So at 3:45. Okay. All right. What do you need to find the location of point P marked on the clock? Okay. What would you need to find? Well, we would need to know how high the clock is off the ground. Maybe a ruler. The radius would be helpful. Something to measure from. Maybe some type of scale. Those all would be helpful. All right. All right. Work with the partner to determine how they can calculate the y-coordinate of point P. So the radius is 4. We know the x-coordinate is 3. Let me let's see here. Can I draw a triangle here? Let's do this here. If I were to make this into, I don't want an arrow in there. If I can make this into a right triangle here, if I look here, this is my right triangle. I'll highlight it. Right triangle. The hypotenuse is 5. The radius is, the x-coordinate is 3 because you can get it right there from the coordinate on there. We would need to find the y-coordinate. So couldn't I just do a Pythagorean's theorem? 3 squared plus y squared equals 5 squared. I get y equals 4. All right, so I know it's going to be positive 4 because it's up. I'm assuming this is the origin, 0, 0, if this is 3, comma, something. So your answer is 4, okay? All right, here's another one. What's the radius of the circle? So I know the x and the y coordinates, so here's what I'm going to do. I'm going to make a triangle, make a right triangle. Right there. So if the x-coordinate is -5, this side is 5. Well, really -5, but since it's a triangle, I guess we could call it -5. That's fine. Call this 12. Here's my right angle. So I'm going to call my radius C. So if I took -5 squared plus 12 squared, that's going to give me C squared. 25 plus 144. equals c squared. So I get 169 equals c squared, square root, 13 equals c. So the radius is 13. If Q has a y coordinate of -4, so here's Q, I go to the second picture. What is the x coordinate? So they give us the radius. Let's draw a triangle again here. So I'm going to take this, always take my triangle up to the x-axis here. And I'm just doing a little bit of geometry. There's my right triangle. So if this is 5, has a y coordinate of 4. So it's, we want to know the x coordinate, the y coordinate's 4. So this side of the triangle is 4. The x would be horizontally. So it's going to be x squared plus 4 squared equals 5 squared. X squared plus 16 equals 25. X squared equals 9. When I square root both sides, I get x equals 3. Okay? Oh, I guess I skipped 2. Oh, shoot. I guess I got to redo that. Whoops. All right, let's do that again. Has a y coordinate of -4, not 4. So it's going to end up being the same thing, I guess. X comma -4. What you're starting to see here is it's going to end up being the same thing. X squared plus -4 squared equals 5 squared. And you do this, it's 16, 25 again. And we get x equals 3. So it's the same answer. So you're going to, I guess I kind of already did the next one here. Your triangle is going to look like that. Okay, right there. So the y coordinate's 4. We're looking for x. So the y goes there. And again, it's a right triangle. I didn't put my right angle on the last one. So for 3, it's going to be 4 squared plus x squared equals, the radius is 5. Going to get the same thing when I do my algebra. I get x squared equals 9. Square root, we get x equals 3. Now here's the thing. We went left 3 here. So look at where we're at. This is the origin here at 0, 0. So if I go left 3, you kind of got to know it's -3. Now technically, I guess I kind of skipped this. When you square root both sides, technically you have plus and -3 for both of these. So I guess you got to look at your picture and figure out where we are. So since I went right, it's not going to be -3, it's +3. And this one here is plus or -3 as well. But since I went left, it's technically going to be x equals -3 for that one. Okay? And the last one, number 4. A circle centered at 0, 0 has a radius of 10 feet. Point S on the circle has an x coordinate of 6. What's the y coordinate of point S? So I'm going to draw a picture here. They didn't give us a picture for this one. So here's my x, y. There's 0, 0. I'm going to put the circle right here. All right, it has a radius of 10. Point S on the circle has an x coordinate of 6. So that means I go to the right, 6. 6, comma, we don't know the y coordinate. So the radius is 10. So kind of means like a little bit past halfway here if the radius is 10. I could actually have 2 different points here, okay? These points here could be 6 to the right if this is 6 on the x-axis, and this would obviously be 10. You could have two different spots there. It could be in either one of those. So I'm going to do 2 triangles. The only difference is you're going to end up actually having the positive and the negative, like we had on the last ones. We won't choose one. We'll actually just have both. So, if this was my triangle right here, let me highlight it here so you know what we're looking at. That's my triangle. Radius is 10. The x coordinate is 6. We want to find the y coordinate. So that's going to be 6 squared plus y squared equals 10 squared. 36 plus y squared equals 100. ends up getting me y squared equals 64. And when you square root, you kind of have to have a plus and minus there. So here's the thing, the plus is up here. This is going to be at positive 8. So this is 6, positive 8. And then this point down here, if I drew the same triangle, this would give me 6, negative 8 down there. So I guess you have 2 answers there. It could be 8 or negative 8 in that case. Now, if they told you which quadrant it's in, like if they said, oh, it's in quadrant 1, or it's in quadrant 4, okay, they always use Roman numerals for quadrants, then you could figure out which sign it was. Quadrant 4 would be negative 8. Quadrant 1 would be positive 8. All right, consider what is true about x and y coordinates of the ladybug if the clock is centered at 0, 0. So obviously, what is true about x and y coordinates? So, you know, they are going to repeat as the ladybug travels around the clock. What else? They will reach a maximum at 12 and a minimum at 6 on the clock. Consider how the values of the coordinates change as time passes. I would say that if depending on where you start, they increase or decrease. If you start at the top like we did, they decrease and then increase and then they repeat. Okay. Here's a circle with radius of 15 units whose center is at 0, 0. If the y-coordinate of point C is 12, what is the x-coordinate? So this time we know which quadrant we're in. So we know the x-coordinate is negative if I go left. So, you know, I'll just draw my triangle right here. So this is 15 out here. I'm going to move my 15 over here. It looks a little bit better. So the y-coordinate is 12. So we don't know x. We need to find y. So y is 12. Here's x. Do a little Pythagorean's theorem. 12 squared plus x squared equals 15 squared. Let's see here. 225 minus 144. I think that's 89. Or 81, I meant to say. Square root, square root. So x equals, technically it's plus or minus 9, but since I went left, we know that it's going to be negative 9. It would have to be the coordinate. It'd have to be this point right here would be negative 9, 12. Okay? Name 2 other points that must be on the circle. Well, if I move that point down here, this would be pretty much the same x-coordinate. It'd be negative 9, but now it's down here at negative 12. That would work. If I move that right here, so it's the same height here, that would be positive 9, positive 12. So here's another point, and technically if I went down here, it'd be positive 9, but negative 12 down here. Okay, so I named 3 extra points, okay, because I wanted to try hard there. Okay, I think that's it. Hopefully you enjoyed this video. Thanks for watching.
All right, in the bridge, we have a picture of triangle ABC. So that's going to be the red triangle on the top. Here's point A, here's coordinate B, and here's coordinate C. Now we want to label the points A prime, B prime, and C prime on the triangle that's been reflected, the blue triangle on the bottom. once we fold that over the x-axis is being used as a mirror. All right, so now the first thing I'm going to look at is B prime because that's going to be the same point. So I'm going to label that first. So B prime is simply 10, 0. Same exact point. All right, now I'm going to take point A, and it's across 5 and up 5. So the x-coordinate is still going to be 5 because we're going to go across 5. And this time we go down 5. We're going to go down the same distance. So we're going down 5. So B prime is 5, negative 5. Okay, and now C prime, we're going to go across 20 and down 10. C prime is 20, negative 10. All right, now we want to label the points A, B, A prime, B prime, C prime on the triangle. All right, so we've done that. So for question number 2, what do we notice about the original triangle compared to the vertices of the reflected triangle? So let's first write those down. A prime is 5, negative 5. B prime is 10, 0. C prime is 20, negative 10. And what I notice is that the x-coordinate values are the same, but the y-coordinate values are opposite because we went below the x-axis. We're going down in the y direction. Number 3 says, imagine triangle ABC is reflected across. So again, we're looking at the red triangle, and we're going to reflect it this time across the y-axis. We want to predict how the coordinates might change. So I'm thinking we're going to go in this direction. Now we're reflecting it across the y-axis, which means we're folding it over the y-axis. So the x direction is going to change. So I think that the x-coordinates are going to become negative and the y-coordinates are going to stay the same. So pick up a piece of patty paper and trace the red triangle, A, B, C, and then fold it over and then lay it across the y-axis. Did you come up the coordinates A double prime as 5, negative 5, B double prime as 10, 0, and C double prime as 20, negative 10? Notice that the x coordinates stay the same. The y coordinates change. Okay, that was what, let me look closely again, that was what happened when we reflected across the x-axis. So I think that this is going to be negative 5. The y is going to stay the same. The x is going to change. The y is going to stay the same. The x is going to change, and the y is going to stay the same. All right, make sure that you draw that, double check and make sure that we've got the right coordinates. So let's draw those in. A double prime is negative 5, positive 5. C double prime is negative 20, positive 10. And B double prime is negative 10, 0. All right, on the warm-up, the x-coordinate of a point on the unit circle is 3, 5. All right, in this activity, I'm going to let you think for a little bit. All the points are 1 unit from the origin. Choose one of the points. Now describe its location using only words. Now the challenge is to use as few words as possible. Now we're going to come back as a class and we'll see this completed in the classroom. The person, I'll choose a person to read their description, and then we'll all try to guess where that point is and mark it on the board. So we're going to see whether we're using angles to describe how to get to those points, whether we're using coordinates. Just dig deep and think about what you've learned to describe how to locate one of those points that you choose. All right, for this one, we're going to draw and label angles. Now, I've took those angle measures and they're in radians, and I've converted them to degrees. So that, because if I take pi over 12 and multiply by 180 over pi, I get 15 degrees. And it's easier for me to visualize or to kind of guess where 15 degrees is. So I'm going to start with pi over 12, and I'm going to see if I can put that on that circle. Okay, start at 0 pi. If you go all the way around, we've gone around 2 pi. Halfway around the circle is 1 pi. A quarter of the way around the circle at 90 degrees is pi over 2. And 3/4 of the way around the circle is 3 pi over 2. Okay, pi over 6. If you multiply by 180 over pi, that's about 30 degrees. And remember, pi over 12 is about 15 degrees, so about half of that. And then pi over 4, that converts to 45 degrees. And 45 degrees is half of 90 degrees. So that's easy for me to place it. Now, if we were to go around, we could keep adding 5 pi over 12. And then we could keep going around the circle. But we'll just stop in the first quadrant. All right. In this activity on page 24, take a few minutes to write down something that you notice and something that you wonder. All right, we're going to be looking closely at the unit circle. All right, we have, other than 1, 0, 0, 1, -1, 0, and 0, -1, the coordinates that we used in this activity involved approximations. The point 0.8 or 8/10 and 6/10 lie exactly on our unit circle. Explain why this must be true. So on page 26, think about that. Think about the Pythagorean theorem and why you think that must be true. And then find all other points that lie exactly at the intersection of two grid lines. All right, we're going to complete the cool down and the study.com assignments in Google Classroom. That will give you more information and really focus on those, and then complete the quizzes at the end. You'll get 2 chances. You'll actually have more than 2 chances, but I'm only going to average the first 2 attempts in study.com as the grade that goes in the grade book. Now, don't forget to read and highlight the vocabulary in the summary and glossary, and use the vocabulary study set for the Unit 8 in Quizlet. And we'll review on Thursday and test on Friday. This is going to go very quick. Remember, it's an overview. Turn to page 23 in your workbook and follow along to fill out the parts of the unit circle.
So the way that you memorize the unit circle is basically by just memorizing the first quadrant. So only memorizing the first quarter of the circle, and the rest you can kind of use in order to replicate it. So you want to know that we have 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees filling in this first quadrant. These angles are going to replicate themselves as they go over to the left. So I know on the left-hand side, half a rotation is 180. This angle is 30 degrees, so all I do is subtract 30 to get 150. I know that this over here is 45 degrees, so all I do to find that next one over there is subtract 45 degrees, and I end up with 135 degrees. For this section here, I know that that's a 60 degree angle. I just subtract and I get 120. and I continue this pattern on as I go. Here I need to add the 30, so that gives me 210. Here I need to add 45, so that gives me 225. Here I need to add 60, so that gives me 240. And then when I add that extra 90 degrees, this one here is going to give me 270. Here I know that a whole rotation is 360, so it's a similar thing over here. To find this angle here, I'm taking that 360 degrees and subtracting 30. For that next one over, I'm subtracting 45, so that gives me 315. And for this last one over, that one's going to give me 300 when I subtract 60 from 360. We'll focus more later on how to convert into radians, but when we look at angles, there are measures that are degrees, and there's another way to measure them in radians. For this first quadrant, the first one is 0, the second one is pi over 6, the next one is pi over 4, the next one is pi over 3, and then this one up here is pi over 2. Now half a rotation is pi, so when we start to replicate things over, we're just taking, for this one, pi over 6 away from pi. So that leaves me 5 pi over 6. For this one here, I'm taking pi over 4 away from pi. So that leaves me with 3 pi over 4. With this one here, I'm taking pi over 3 away from pi. That leaves me with 2 pi over 3. We continue on, we add pi over 6 to this one here, we get 7 pi over 6. We add pi over 4 to this one, we get 5 pi over 4. We add pi over 3 to pi, and that's going to leave us with 4 pi over 3. And then this one down here will be 3 pi over 2. Same thing here, one full rotation is 2 pi, so we're taking the radians away from 2 pi as we continue on this one here. So if I take pi over 6 away from 2 pi, that's going to leave me with 11 pi over 6. If I take pi over 4 away from 2 pi, that's going to leave me with 7 pi over 4. If I take pi over 3 away from 2 pi, that's going to leave me with 5 pi over 3. So that's just simply filling in the into the angles in both radians and degrees. Now what we found when we did special triangles last year is we found coordinates that correspond with each of these points. So this one is 0, 0. This one here is root 3 over 2, comma 1/2. This one here is root 2 over 2, comma root 2 over 2. This one here is 1/2, comma root 3 over 2. And then when I get up here to 90 degrees, it's 0, comma 1. Now these here match throughout the whole unit circle. So when I am filling in the unit circle, I only need to have that first quadrant memorized, and then from there on out, I can fill in the rest. Let me erase this real quick. This was 1, comma 0. So I'm going to go ahead and I'm going to fill in the rest of my unit circle with the same exact thing I have in each of these quadrants. So I have 1/2 root 3 over 2, root 2 over 2, root 2 over 2. root 3 over 2, 1/2. 1, 0. And then root 3 over 2, 1/2 over 2, root 2 over 2, 1/2 root 3 over 2, 0, 1. Then here I have this root 3 over 2, 1/2, root 2 over 2, root 2 over 2, and then 1/2 and root 3 over 2. So the only difference between each of these quadrants is the sign that it has. So here on the left-hand side, in this second quadrant right here, see how I kept the same numbers in each of those things? The only thing that is different is that the x values in this quadrant are negative, the y values are positive. So I'm just going to add a little negative in front of all these x values because they're on the left side of that axis. Versus this one down here, both my x and y values are negative because they are both below and on the left. So on these ones, I'm making everything opposite. And then on this side over here, my x values are positive, my y values are negative. So I'm just making all of those y values opposite. So that's how we fill in your unit circle. Make sure that you have everything copied down perfectly, and we will be quizzing on this next week.